Right, today we are talking 7.2 parallelogram properties. We are live in period 2. We're going to talk a little bit about a couple different theorems and then get into just a few practice problems. But first, what is a parallelogram? Okay, a parallelogram is a four-sided figure that has each side parallel to another opposite side. If a quadrilateral is a parallelogram, speaking of which, four sides means quadrilateral. So if a quadrilateral is a parallelogram, then its opposite sides are also congruent. So if you have two pairs of parallel sides, then each of those sides is also going to be congruent as well. So it shows you like PQ and RS are equal to each other, QR and PS are also equal to each other there. Next, you've also got parallelogram opposites angles theorem that says if a quadrilateral is a parallelogram, then its opposite angles are congruent. So as you can see through that, because it's a parallelogram, meaning the sides were parallel, the opposite angles, like Q and S, would be equal or congruent to each other. P and R would also be congruent to each other as well. Parallelogram consecutive angles theorem. Remember consecutive interior angles from way back? Talked about two angles on the inside that were equal to 180. So in a quadrilateral, if we have consecutive angles, they are equal to 180. Which will kind of make sense because x, if you look at this, x plus y equals 180. These would be equal to 180. Okay, you could just kind of go around here. They're right beside each other. These would be equal to 180, equal to 180, and equal to 180. Because it's a parallelogram, okay, that means that it's a quadrilateral, and quadrilaterals have 360 degrees inside. If you do the n minus 2 times 180, 4 minus 2 times 180 gives us 360. Last but not least, we have parallel diagrams theorem. I'm live right now, so can you give me like 2 minutes? Okay. If a quadrilateral is a parallelogram, then its diagonals are congruent as well. So if you take a look, diagonals means that you go from one corner all the way across to the next. If you were to bisect those, those two, QM and SM would be congruent. You'd also have PM and RM would also be congruent as well. Knowing this, we can go ahead and go to our first checkpoint here, which kind of is just a little bit of practice and pretty much the end of our notes for this first part. So finding FG and the measure of angle G, we have to look at what they are giving us. First off, they show us here, I'm just going to highlight, they show us that these two sides are parallel. They also note that these two sides are parallel as well. That makes this a parallelogram. Because of that, if HE is equal to 8, then GF or FG would also be equal to 8. Because this angle E is 60 and the opposite angle is angle G would also be 60 degrees. And that's how we're able to find those angles. Now, if they wanted to ask us what angle F was or angle H, we just subtract from 180. So 180 minus 60, we get those 120 for angle F or H. If they asked us for FE or GH, however, we would not be able to give them those sides because we don't have a measure. So example 1 just talked with numbers. Example 2 now has variables. So find the value of X and Y. Again, it gives us the symbols that this is a parallelogram. Opposite sides are parallel. That means opposite sides are congruent, opposite angles are congruent. So how could I set up an equation to solve for X? Anyone want to chime in as to how you would solve for X? Yeah. Good. So 50 equals 2X. So then X is equal to 25. Since those are opposite angles, that means that those two angles are congruent. What about Y? Yeah.
18 equals y plus 3.
Good. So 18 is equal to Y plus 3. Those are opposite sides, meaning they're congruent. And Y is equal to 15. Questions so far? All right, not too terrible. All right, and example number 3, find the indicated measure in the parallelogram. So it tells us the parallelogram JKLM. State the reason. For example, opposite sides of the parallelogram are congruent. Opposite angles are congruent. Diagonals are congruent thing. So let's take a look. NM. NM is the small line that's located here. Trying to find. Because it shows our diagonals, NM should also be congruent to KN. So NM is equal to 2. Diagonals are congruent. What would that give us for KM then? 4. Good. KM would be 4. That's the total of the diagonals. So what's the measure of JML? So let's find out where that is. JML. JML looks like it is this angle down here that I've put in red. So if it tells us that angle J is 110, how could I find the measure of M or JML? Subtract from 180. So I'm going to take 180 minus 110 to get 70 degrees. And that's because they are consecutive, what you consider consecutive angles. And consecutive angles equal 180 degrees. All right, so last but not least, they're talking about KML. So I'll do that one in green here. KML is this little side. So we know the whole entire angle is 70. They've asked us for the little side, and we know that this is 30. One of the other sides is 30. So KML would be 40 degrees. And that's because we took the 70 that we found from the consecutive angles, subtracted 30 degrees, because that was what they gave us as the inner part of that angle, to get our 40. Questions on example 3? All right, last but not least, determine M and P in the parallelogram. How could we find the measure of angle P in the parallelogram below? Good. We'll take 4 times P plus 3 equals 135. So 4p plus 12 equals 135. 4p is equal to 123. And then p is equal to, can you say that a little louder for me? 30.75. So now that we know that p is 30.75, that should be good for there. How could we find out what m would be then? So separate. How could we find the measure of angle m? Yep.
Could you do 135? I mean, 180 minus 135?
Good. So 180 minus 135, which will give us 45 degrees for the measure of angle m. Good work.